All right, so here we have a thunderstorm occurring. It says the temperature drops and then rises again during this thunderstorm. The rate of change of the temperature during the hour and a half after the storm began is given by our little t of h, and the output's measured in degrees Fahrenheit per hour, and h is the number of hours since the storm began. All right, so this is our rate of change function. And calculate the average rate of change of temperature from 0 to 1.5 hours after the storm began. Well, what we could do there is, since it's rate of change, what we could do is we could say, okay, well, let's take, excuse me, the interval from 0 to 1.5 of our t of h d h, and that's going to give us, oh yeah, we have to divide by 1.5 minus 0, and that should give us what we need. So as usual, I've got our equation in here. And so what we can do is we can do math 9, 0 to 1.5. This is in alpha 1. And then we move it over to x. And then we divide by, and it's 1.5 minus 0, which is just 1.5. So we get a negative 0.454. So we get negative 0.454, and that's going to be what? Degrees Fahrenheit per hour. All right. Now, if the temperature was 85 at the time the storm began, well, so that means that T equals 0, the temperature was 85, so T of 0 equals 85. Okay, so what could we do? Well, what we're going to have to do is we're going to have to figure out how do we find this capital T. Well, how do we find that? Well, we're actually going to have to take that integral. So capital T of H is going to be equal to the integral of TH DH, and so we're going to have to get that. So that's going to give us 9.48 H to the fourth divided by 4, and then minus 15.49 H to the third over 3, and then plus 17.38 H squared over 2 minus 9.87 H plus our nice little C. Okay. Now, what do we know? Well, at time 0, so all our h's are 0, it was 85. Well, if 85 equals 0, 0, 0, 0, that means C is going to be 85. Okay, so we just plugged in what we knew, zeros for h's, so that goes to 0, that goes to 0, that goes to 0, that goes to 0, and all we're left with is C is equal to 85. So that means our T of H is, let's just leave it like that, 9.48 H to the fourth over 4 minus 15.49 H to the third over 3 plus 17.38 H squared over 2 minus 9.87 H plus our 85. So that's what T of H is. Now what we have to do is we have to actually do our integration, okay? Because now we need to find the average temperature. So now we're going to integrate this. And so do we have another page? Yes, we do. And so we're going to integrate from 0 to 1.5 our capital T of H dH. Now that's going to be equal to what? Well, oh yeah, and we're finding the average. So we have to divide by 1.5 minus 0. All right, so now we have to plug in all that into our calculator, and that one I don't have. So what we have to do is we're going to have to change that to a 4. Yeah, let's go ahead and change it. I don't think we have to do anything else with this problem. And then come down, and then we'll insert divide by 4. And we'll come over here. That becomes a 3. Come down, insert, divide by 3. And then come over, and then we're going to have to insert squared and divide by 2, and come over and put an x, and then we have to also remember to put in that plus 85. All right, so that's our new function. Now we can come back over here and we can do our integration. So we're going to do math 9, 0 to our 1.5. Now this is still in y1, and then we go over here to x, and we're dividing by 1.5, and that should give us our average temperature, which says it's 82.158. And that should be just degrees Fahrenheit. So what else does it have us do? That's all. So again, what we had to do is we had to do our calculate that average rate of change of the temperature. So that's going to be that. Then we had to find if that was the temperature, what is the average temperature? And so we had to take the antiderivative of our rate of change function to get the temperature function. And because they gave us a point up here, we had to find out C. So we added that in. And then we took the integral from 0 to 1.5 of capital T of H, which is the temperature function, divided by 1.5 minus 0 to get our average temperature. Okay. All right. So that looks good. Let's see. How about oil production? So oil production, on the basis of data obtained from a preliminary report by a geological survey team, it is estimated that for the first 10 years of production, a certain oil well in Texas can be expected to produce oil at the rate of this here function here. And he is in that. Calculate the average annual yield from this oil well during the first 10 years of production. And then during the first 10 years, when is the rate of yield expected to be equal to the 10-year average? All right, so what we're going to have to do for A is we're going to take for the first 10 years, so we're going to go from 0 to 10, and we're just going to take the integral of R of t dt divided by 10 minus 0. Okay, so let's go get in our calculator. And clear that. And so now we have the function in here, so we're good there. So now we can just do our integral from, and it was 0 to 10 of our alpha 1. And then we'll put our x. And we're dividing by 10 minus 0, which is just 10. And so it looks like we get 1.245 for our value. So let's make sure we have our right function in here, 3.93. Oh, we don't have the function completely correct. 5x to the 3.55. Okay, now let's go back here. Oh, that's not good. Guess what? We have to type it all again. All right, so we have 3.935, and then that's x to the 3.55, and then that's e to the negative 1.351 x. All right, so now let's go here, and now we can do this again. 1.247. All right. Not much difference, but I was like, I just want to make sure because sometimes I type those problems in wrong. Like you saw, I forgot the 5. So our value here for the first piece was 1.247, and that's going to be 1,000 barrels per year. Okay. Now it says during the first 10 years, when is the rate of yield expected to be equal to the 10-year average? All right, so what we need to do is we need to plug that in and get into our value. So we're going to basically say, well, when is 1.247 equal to R of t? Okay. Well, that's going to be when? Well, we plug it into our numerical calculator. It lets me share the screen. And we want that to be equal to the 1.247. And then we want this one to be y1. And we should be able to get a value. Okay, so what about anything closer down? All right, so 1.099. Now, let's write both of those down, 1.099, and what was that other one? 5 something, 5.165. All right, so let's go and look on our graph what that looks like. Okay, and so what we want to do is get our values here, and let's do this. Let's plug in our 1.247 to kind of see where it is. So we're going to have one hit here and one hit here. So that's really what's happening there. So let's go back here, and I better go get that. It's 1.099, but I forgot the second one already. Let's go back here and 5165. So those 2 points are going to be equal to the 10-year average. Okay, so at 5.165 years and 1.099 years. So that's going to be the 2 pieces that's going to be. So, you know, I'm not sure, you know, if we really have to go and explain any more than that as far as what month and day, but it's 5 years and just into the 6th year. This is 1 year, so it's just into the 2nd year. So that's kind of how to look at that one. All right, so let's stop there and we'll come back for more.